Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine standing atop the jagged peaks of a massive mountain range, the air thin and the silence profound. Beneath your feet, millions of tons of rock are locked in a silent, titanic struggle. We often think of mountains as static, immovable monuments to deep time, but science is revealing a much more energetic reality. These massive geological structures are not just piles of stone. They are gargantuan natural batteries, humming with electrical potential. This phenomenon is known as the Piezoelectric Peak, a fascinating intersection of geology and physics where the immense stress of plate tectonics is converted directly into electricity. To understand how a mountain can become a battery, we have to look at its most basic building blocks. A significant portion of the Earth's crust, especially in continental mountain ranges, is composed of quartz. Quartz is one of the most common minerals on our planet, found in abundance within granite and sandstone. But quartz is special. It possesses a unique property called piezoelectricity. Derived from the Greek word piezein, which means to squeeze or press, piezoelectricity is the electric charge that accumulates in certain solid materials in response to applied mechanical stress. On a microscopic level, quartz crystals have a non-symmetrical atomic structure. When you apply pressure to these crystals, the internal arrangement of atoms shifts, pushing positive and negative ions apart. This displacement creates an electric dipole, effectively turning each grain of sand or vein of quartz into a tiny battery with a positive and a negative end. Now, take that microscopic effect and scale it up to the size of the Andes or the Himalayas. When tectonic plates collide, they exert unfathomable amounts of pressure on the crust. We are talking about trillions of tons of force grinding against each other for millions of years. This mechanical energy doesn't just go into folding the rock or creating heat. It also builds up a staggering electrical charge within the mineral lattice of the mountains themselves. For decades, geologists and physicists have theorized that mountain ranges act as massive capacitors, storing electrical energy until the stress becomes too great and the rock eventually fractures. One of the most haunting and beautiful pieces of evidence for this, earthly electricity, is a phenomenon known as earthquake lights. For centuries, people living in seismically active regions have reported seeing mysterious glows, floating orbs, and flashes of blue or white light emanating from mountain ridges shortly before or during a major earthquake. For a long time, mainstream science dismissed these reports as hallucinations or misidentified lightning. However, with the advent of high-speed cameras and sensitive electromagnetic sensors, we now know they're very real. These lights are likely the result of the massive piezoelectric discharges occurring deep within the Earth's crust. As the tectonic stress reaches a breaking point, the accumulated electrical charge is released, ionizing the air above the peaks and creating a luminous display that mimics the aurora borealis. But the implications of these natural batteries go far beyond light shows. Scientists have observed that this tectonic electricity can actually interfere with the ionosphere, the upper layer of Earth's atmosphere. The electrical field generated by a stressed mountain range can extend miles into the sky, potentially disrupting radio communications and satellite signals. Furthermore, researchers are investigating whether certain animals are sensitive to these subtle changes in the local electromagnetic field, which might explain the legendary ability of some species to sense an impending earthquake hours or even days before the ground starts to shake. They are literally feeling the battery of the mountain reaching its maximum capacity. Is it possible that we could one day harvest this raw, geological power? While we are currently far from plugging our cities into the side of Mount Everest, the concept of geoelectrical harvesting is a burgeoning field of study. If we could develop sensors capable of capturing the trickle of piezoelectric energy from active fault lines, we might create a source of renewable energy that is as constant as the movement of the continents themselves. More importantly, monitoring the charge of these mountain batteries could provide us with the ultimate early warning system for earthquakes. By measuring the electrical fluctuations within the rock, we might be able to predict a seismic event with unprecedented accuracy, potentially saving thousands of lives. The next time you look at a photograph of a mountain range, don't just see cold, dead stone. See a living, breathing electrical engine, a testament to the incredible forces that shape our world from the inside out. The piezoelectric peak reminds us that our planet is a complex, interconnected system where the movement of a continent can spark a light in the sky. For more incredible facts like this, don't forget to subscribe and turn on notifications.